So we are trying to project the vector 6, 0, 0 onto the span of 1, 1, 1 and 0, 1, 2. And our hint is find the projection matrix P, which is helpfully formulated here. So I need to find my projection matrix P. Really, my plan is going to be to find all kind of 4 of the pieces of projection. So I'm going to find x hat, I'm going to find P, I'm going to find B parallel, and B perpendicular. What is my vector B in this case? Good. B is going to be 6, 0, 0. So that's going to be my vector B. Where is my matrix A all up in this mess? Good. A is going to be the matrix that has columns made out of your
basis.
Yeah, a basis for your spanning set, for your span, right? So I need to make sure that those two things are indeed what?
Linearly independent.
Good. I need to be sure that those things are linearly independent. Why?
It doesn't work.
Because it doesn't work otherwise is the kind of perfect, easy answer. What is the slightly more complex answer? Which part doesn't work?
It won't be invertible.
Good. A transpose A won't be invertible, and you'll be hosed right there. So slim that set down until it's linearly independent. Is this set linearly independent?
Yes.
Yes. Cool. All right. So I need to calculate and I tend to calculate these by hand in pieces. You can put this in a calculator if you want, but I'm just going to do it by hand in pieces. So the first piece I start with is A transpose A. So I'm going to say, all right, that's A. A transpose is going to be that thing transpose, right? So we're going to do 1, 1, 1, 0, 1, 2. Okay, so I need to do 1, 1, 1, 0, 1, 2. Oops. Crap. This is where I screw up. I screw these up. If you get the order wrong, the problem won't work, or the formula. Wow. Yeah, if you get the order wrong, you're not doing the formula. If you're not doing the formula, it won't work. So I need to fill this into the other order. So I'm going to do A transpose A first. So that's going to be 1, 1, 1, 0, 1, 2, multiplied by 1, 1, 1, 0, 1, 2. Good with me?
Do you want it? Or do you want to do
I mean, by hand's not so bad. So I pick this up, drop it on, I get 3. 1 times 1 times whatever.
Yeah.
And then if I pick this up, drop it on, I get
3 again.
also 3. If I pick this up and drop it on, I get
3 again.
also 3. And if I pick this one up and drop it on, I get
5.
5. I was really expecting also 3. You know how weird that was? Okay. Alright, so what do I do with that?
Invert it.
Yeah, I need to invert that. If it had been also 3,
It would be not invertible.
it wouldn't have been invertible, and that would have been a clue to me that I started with vectors that weren't linearly independent, right? So, this is going to be invertible, and I need to calculate its inverse. So, do you guys remember the 2x2 matrix inverse trick?
You augment it with
Over the determinant of A.
No,
I
not the
meant to
trick.
say.
Yeah, 1 over the determinant of A.
That's what it is.
So, the determinant is 15 minus 9,
Which is 6.
6. So, I've got 1 over 6.
Times, okay, so there's A, B, C, D. Okay. A and D are left alone, right?
No. A and D switch places.
Okay.
B and C are left alone.
So you switch the diagonal.
Yes.
So that's,
5.
I end up with a 5 and a 3. And then I negative the other two. So you swap both, right? You swap the positions on the diagonal and the signs on the anti-diagonal. So, oop, that was not a 3, Joe. Minus 3 and minus 3.
Yes.
You guys good with this?
Yep.
So that's my A transpose A's inverse. And then what do I need to do with that?
Now we need to do A transpose onto that. Right?
Yeah, so I need to do A transpose on the right and A on the left. Guys with me?
Store that makes because A transpose is on the
Right.
right
So
and
that's
A is on the left.
Yep.
You said that in reverse.
Oh,
A transpose on the right, A on the left.
it is pretty simple.
Oh.
I don't know. It doesn't matter. I may have said it backwards. We'll know in the video. So, my next step on these is to calculate. No, that's lazy. I shouldn't have done it that way in my notes. So my next step on these is going to be to calculate this thing times A transpose.
yeah.
And that's my next step because I'm really kind of after X hat. Is with me? So let's calculate. We're going to go after X hat for a second here. So I need my matrix from the other side, so I need A transpose A's inverse times A transpose, right? So on the other side I got, that's a sixth, and then I got 5, -3, -3, regular 3. So that's the A transpose A's inverse. And then here I need times A transpose. Right, and A transpose was 1, 1, 1, 0, 1, 2. Guys with me?
Yes.
Okay, so that's going to get me a sixth times. How big is my matrix going to be? This is 2 by 2.
So it's 3 by 2.
That's
2 by 3.
better be 2 by 3, otherwise this isn't going to work, right?
Yeah, I bet.
So I'm expecting to get a 2 by 3 result. Okay. So, pick this guy up and drop it on.
That's
5.
So that's going to give me a 5. Pick this up, drop it on.
That's good.
-3.
It's going to be -3. Pick this one up and drop it on.
2,
2.
0,
Pick this one up and drop it on. 0. This guy.
-1, 3.
Perfect. Very nice, guys. Okay, so that is my A transpose A's inverse times A transpose matrix. Okay, what am I after? So if I'm after X hat, I'm going to do this matrix to my B vector. Right?
Yeah.
If I'm after the other matrix I need, right, which is the P matrix, I need to do A to the left-hand side of this. You guys see that? So, this is one of these cases where cramming it in a calculator is not a bad idea, right? Because you're going to get all this stuff done a lot faster. You can maybe do it by hand just to like practice some matrix multiplication. If you do it by hand, step, 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 basically. So let's figure out our projection matrix. So our projection matrix P, right, is going to be A done to this thing. So that's going to be, I need my matrix A, which was 1, 1, 1, 0, 1, 2. I'm going to have my 1/6 just kicking in the middle. And I've got a 5, 2, -1, -3, 0, 3. Okay, what do you do with your 1/6 kicking it in the middle?
Just put it in, put it on the end.
Yeah, pull it out. One of the sides. I tend to pull scalars to the front.
Makes sense.
Okay, so now what size am I expecting the result to be?
You're expecting 3 by 3?
So we have a 3 by 2 and a 2 by 3.
Okay, 3 by 2 times 2 by 3 should be 3 by 3 result. Great. Okay. So, let's see. This one I happen to have written down, so we don't have to do it. So this is going to give me my 1/6 out front, and then my matrix is going to be 5, 2, -1, 2, 2, 2, and -1, 2, 5.
Heck yeah, that's on there too.
You got that? Did you notice the thing about that?
Oh, that's
Yeah, that's symmetric.
It's symmetric.
yeah.
Why is it symmetric?
Because it's made of A transpose A.
Yeah, I think it's basically symmetric because it's made of A transpose A's. You guys see that?
Yeah.
To know for sure, we'd have to.
Like there was that thing about A transpose A was always a symmetric matrix, right?
Yeah. Which implies that.
And A transpose was also always a symmetric matrix.
It's a symmetric matrix.
What's yeah, it's like a little weird to be like, oh yeah, it's symmetric. Like, yeah, that does keep happening.
It's just pulled apart. It's like, okay, we stayed, but then over here. Like,
Yeah, so I would bet you almost anything that there's a homework problem that says discover that projection matrices formulated this way are symmetric. I'll leave that one as you guys can figure that out. So I got this. Great. Now where do I get my pieces? So I got my matrix P, right? So
P times B will get you B parallel.
yeah, so let's like get our pieces, right? So B parallel is P times B, right? So I'm gonna just take that thing and multiply it quickly by 600, right?
Yeah.
So that's gonna be a 6. And then multiplying this thing by 600 is gonna be pretty easy, right?
Yeah.
The second two rows are going to zero out every time, or the second two column entries are going to zero out every time. So I'm just going to get 6 times 5, 2 times 6, and negative 1 times 6.
So 30, 12, and 56.
Yeah, and then the 6 is going to cancel with everything anyway. Right. So I'm going to get a 6 times 30, negative 12.
No, I just meant like put the
Positive
6
12.
into that first.
Yeah.
Yeah, totally. You can cram the. Okay.
It's,
Fine.
well, then it'd just be 1.
Yeah, then it's 5, 2, negative 1.
Yeah.
Yeah.
Rad. Cool. So that's B parallel.
And then B perpendicular is B minus that.
And then B perpendicular, right, is 600 minus this, which is going to be
Negative 2.
1, negative 2, 1.
And now we.
And I can check this by adding those two together. I should get B.
Yeah.
Yeah.
Okay, and then what's the other one?
You could do dot product of B parallel without something spanning. So.
Yeah, if we were also going to check, we could take B parallel, sorry, not B parallel, B perpendicular, and dot it with our two vectors A1 and A2, right? So if we dot this with those two vectors, we should get 0 out of both of them.
Yeah.
Do we?
Yes.
We do. Seems like we do. Cool. Alright, kick ass. This seems like it worked. What's the other thing? So I got my matrix P, right?
Yeah.
I got my B parallel, I got my B perpendicular. What's the other thing that... Yeah, the x hat was the other thing we formulated, right? So we may as well write it down. So where do you get x hat from?
A transpose A first. Oh wait, top stuff
Yeah,
times.
this thing times B, right?
Yep.
Yeah.
And once again, I can whack the 6 against the 6, right? And I can notice that I get 5, negative 3.
Sure.
That's
So
so
that-
cool.
And then 5, negative 3, so the x hat vector, is one where if I do A to that, I'll get no,
Parallel?
B parallel.
Yeah.
You guys see that?
That's 6.
Cool. So, how much time do I have left?
None. Minus 2.
Okay, we'll draw a picture next time.